Okay, so this video is going to discuss the cross product property a little bit. We use that to determine whether or not two ratios are equivalent, or said differently, whether or not two ratios are proportional. Now, we've had two problems that we've worked on videos, and let me go to the pad and look at that with you for a second. All right, so we had one, you remember we had this one, which was 5.35, where we had these two values, and we set them up as in ratio and fraction form. Here are the other non-fraction forms. We set them up in fraction form. We wound up doing our cross product multiplication, and we got 12.6, and then we get 12.6. And we said if the cross products are equal, we have a proportion. And so in that case, yep, we had that right. Now we had an earlier problem, which was 5.3.1, where, let's see, we had these two values, 6 and 9 and 7 and 16, and we concluded from that when we did our cross product multiplication that no, we did not have equal cross products. And so therefore we said it was not a proportion. All right, now, what I want to do in this video is just briefly discuss this whole idea of the cross product property in terms of something called the product of the means is equal to the product of the extremes. Okay, and so that really is the cross product property. Now you say, I don't know what you're talking about. Okay, so look, if I tell you that I have two quantity comparisons, A compared to B is equal to C compared to D, if I tell you that that's equal, then what I'm telling you is that the product of B times C is equal to the product of A times D. And that says the product of the means, and the means are referred to as, these are the means, the word means here refers to the meaning of a middle numbers, and not an average, but middle numbers. So the product of the means, which would be B times C, is equal to the product of the extremes, which would be A times D. All right? Now, I just set this one up. It's pretty easy to see this one. And I said, well, what if we had this? And I'm telling you that 3 to 5 is equal to 6 to 10. And I did a little drawing to prove that to you. And I had 5 shapes here. 3 of them have pink dots. 10 shapes over here. What? Yep. 5 shapes here. 3 of them have pink dots. Over here I have 10 shapes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 shapes. And I have 6 of those having pink dots. Now notice how I did it though. I did 1, 2, 3, 1, 2, 3. And I did that so it's clear to you to see that in every group of 5, I have 3 pink dots on 3 of them, right? Every group of 5, I have 3. So you hope that visually helps you see what is meant by a proportional relationship. Now we can also confirm that. How do we confirm it? Cross products. 5 times 6 is 30. 3 times 10 is 30. And, okay, you say, well, where are you going with this now? Now, I want to now use the property of equality, which is nothing more than taking an equation, and you say, well, what equation? This equation, this is an equation. 3/5 equals 6/10. And I'm going to use the property of equality, which says if I do an action on one side of these equal marks, I must do an equivalent action or an equal action on the other side. And I just kind of relabel these A over B and C over D so that when we get down to the end, we can remember what we had. So what here? I'm just going to copy them down as they are. I'm not going to do anything else to them. I'm just going to say 3 over 5, 6 over 10. First thing I'm going to do is I'm going to multiply by 5 on both sides. Okay. Now let's remember that in addition to being 5, that's also B. Yeah, B is 5. So why are you doing that? Because when I multiply through this fraction by 5, if you remember your fraction work, when I multiply this fraction by 5, what's going to happen? Well, the 5 cancel, right? I'm going to be left with 3 equals what? Oh, I got to multiply by 5 over here, okay? And so what will that leave me? Okay, well, it's going to leave me as 6 times 5 over 10. You say you didn't accomplish anything. You still got a fraction on this side. Oh, now let's multiply both sides by 10. And remember now, what was 10? 10 was D. Okay, so 10 in addition to being 10 is D, and 5 in addition to being 5 is B. Okay, I'm just, don't get too confused with me. So when I multiply through by 10 here, the 10s are going, oh, what? Oh, got to do it over here. So now what do I get? Notice I get 10 times 3 is equal to 6 times 5. You say, well, oh, finish it off, finish it off. 30 equals 30. Now, but come back with me. Just come back with me. What was 10? 10 was D. What was 3? 3 was A, yeah. What was 6? 6 was C. And what was 5? 5 was B, right? So look, what is this? D times A and C times B. Oh, remember now, just remember now, goal multiplication is commutative. So D times A is the same thing as A times D, and C times B is the same thing as B times C. I hope that didn't confuse you too much. Now, why did I do this to you? I wanted you to realize there's a reason why using math, you can, or just simple arithmetic, we didn't do anything here, but just a couple of multiplication steps. I can come down here and I can prove that this product of the means equal the product of the extremes, which is the cross product property that we use to prove out whether these ratios are proportional or not. Okay. Let me try to slide this around. Okay. Maybe you can see the whole thing right here, just like that. Okay, so you see how I did that? I'm going to leave that there for a second in case somebody wants to freeze it and look at what's on the pad. So I'm just trying to use this as a way to demonstrate to you why the cross product property works. And I'm going to shift it up just a wee bit so I can pick up what we did down here at the bottom. You with me on that? Okay, so I hope this helps you.